Okay, 2 minutes. So, we now have the ubiquitous black box. We've taken our media, we've done our media hacking, and we now have something different. There we go. Okay, congratulations. Now, you might have something absolutely, utterly brilliant. You might have 5 hours of the greatest hits of the Animaniacs. If you like it, you keep it like a good hack. If you don't like it, you take it back, you clear, you shuffle, you roll back to change it. Guys, that's media hacking. That's what we're going to be talking about in this session. Thank you very much. See you soon. I can guarantee you that one of those 5 people is thinking, oh, my porn was on that thing. He's thinking now, it's got to be one of those other 4 that likes the dog. Okay. And everybody else is thinking, oh, I should have volunteered, that would have been fun. Okay, so we got up here. We've got Camellia, distribution mechanism from Michael Sparks, who we're going to be hearing about later, at the top of the chain. Picking it up, Mike Ryan is going to be talking about Myth TV, what you can actually do when you've received this media. iTunes from Paul is talking about managing the media and rolling back things like shuffles. But to open us up, Matt Westcott, who last year managed to get a streaming ZX Spectrum. Matt is going to be talking about taking his iPod MP3 player and putting Linux onto it so it can play MP3s. Matt.
Right, yes, the iPod, it's clear that from the start it was always designed as a closed platform, an appliance dedicated for doing one job and doing it very well, it has to be said. And right down to the physical appearance of it and the way how unusually for a consuming device like this, no visible at all, so it does lend to this air of don't tinker with this. So nature being what it is, it didn't take very long before people started attacking it with pliers and dremels and found out that what's inside there is actually some pretty standard mainstream hardware. Got an ARM processor, 32 meg RAM, and most obviously a whopping great card disk. And this happens to be just the nice sort of hardware for running Linux on, with a bit of effort. There's a special branch of Linux called UC Linux, which is designed for processors like the ARM without a proper memory management unit. And so back in 2002, a gentleman named Bernard Leach set about reverse engineering the iPod firmware and with the intention of running Linux on it. And I believe Bernard Leach is around here with us today. Somewhere? Yes, so this man I have to thank for all of this, and I'll certainly be buying with it later. So one thing I should mention is that throughout all the development of this, Bernard never actually had to open up an iPod, because despite what I say about it being a closed platform, the software is actually reasonably easy to get at just through the FireWire USB port. The iPod's software itself is actually sort of in 2 bits. There's a fairly minimal bootstrap loader on flash memory, but the bulk of the software is sort of on the disk, on the partition of its own, and that's the bit that iPod Linux touches. So if I using on Linux proper into this graphical user interface, which I'll come on to in a second. So yes, that's all right. So yeah, it's not entirely clear what Apple make of all of this. We can only assume that they are aware of the project, and judging from the lack of lawyers knocking down people's doors, they probably don't mind too much. But having said that, it does seem like whenever there's a new release of the iPod out, then the Apple's engineers seem to delight in throwing these curveballs to keep the developers on their toes. And with one of the major ones came with the introduction of the fourth generation iPods, the one with the click wheel. And in this situation, it turned out that the firmware was actually encrypted on the disk, So it was down to a very resourceful guy named Niels Schneider, who, armed with a bit of code for making the internal piezo speaker of the iPod squeak a bit, actually got it to tap out a memory dump of the iPod in binary. Can you switch back to the... Yeah. Right, so this is a picture of his recording studio, and microphone there. The website does have some fascinating account of the successes and failures of this particular enterprise, and how on the first attempt it actually took so long that the battery ran out before it could finish. So eventually they did get it all working, and managed to extract the firmware, and developers eventually got figured out how the hardware was addressed, first the LCD and the keypad, then after a very long wait we got audio support, which is fairly essential. So the end result of all this is a Linux platform that not only is it all cool and geeky, but it's also vaguely pleasant to write to user land programs on. Because of the sort of weirdness with the memory management, you can't actually have shared libraries so easily on this. So this means that the vast majority of the development has been based around this huge monolithic application with everything but the kitchen sink thrown in, which is aptly called Podzilla. And so you can see it's in action here. It's loosely based as around a clone of the...
Does it have backlight support?
It does, yes. Well remembered. Knew I was missing something. So it's a sort of clone of the iPod firmware with a few additions thrown in. And ranging from the useful to the downright absurd. One of the more useful things that's in the works is of voice audio support, which people feel was lacking from the original. And one addition, which is my contribution, which will be as no surprise for people who watched the talk last time, is a Spectrum emulator. So, I do realise that after my last talk I was accused of wasting all my time on pointless esoterica, so I'll swiftly move on to something that's a bit more practical, and this is something that I would say, it's fair to say, redeems the whole iPod Linux project from being just a neat hack, and this is a spoken interface. It's and there's been a lot of very positive feedback from blind people who are able to use the an iPod for the first time thanks to this. So, yeah.
Do you want to hold the mic for you?
Yes, please.
Hold it on the table and then I can...
Yeah. So, have you got audio feed somewhere? Where did they...
Yep.
That's
Got the mic as well, will you?
Pass that.
Problem with handheld equipment. Hang on.
it takes a couple of seconds to get the spoken interface on. There we go. It's decent time for blind people. Maybe it's not too bad if you don't have the video here. So
time settings,
He's tilted up a little.
playlist, albums, 200K on Edge wrong playing mode, and Google 1966. In Monty, but we was lying.
yeah, so this is where you get all my embarrassing taste in music announced to the world. So
Albums, music,
finally,
with Part Joy.
we'll just go back to the main firmware to show something else that's been very popular, which is a video playback, and it seems to have crashed, so several very experimental lists. So, yeah, so ever since the iPod Photo came out, there's been a lot of speculation that the next big thing for Apple would be video support, so it's nice to head them off on that particular pass. So, just a very second there. And at the moment, it's only it's no sound at the moment. They're working on that, and the only format it supports is uncompressed AVI, and so that's a hard disk space isn't a problem. So
Just talk
yeah.
about that. Yeah, that's good.
There we go. And it does look a lot better on the iPod Photo, but hopefully it should give you a taster of what's possible and what might be to come. So if the want to give this a go yourself, the website is www.ipodlinux.org. It's a very friendly forum. If you have any problems with it. So I think if you're the sort of person to come to an event like this, you probably have no trouble getting it to work. And it works on all models of iPod released to date, with the obvious exception of the Shuffle. Varying.
We know how to hack that now.
Oh yeah. But it's in varying states of support, but it's all working reasonably well on all of them. So if you're content hacking and tinkering with it, then why not check it out?
I don't think I'm going to use this weird microphone business either, I'll just yell. iTunes, I'm assuming you know what iTunes is. It's a music library management and player application, originally for the Macintosh, now also available on Windows. I have no idea if you can get it to work with Wine on Linux, possibly. And it's not desperately hackable, but what I'm going to talk about are some of the ways that you can actually interact with iTunes as a programmer, with scripting, sharing with other machines, and sharing with other applications. So first of all, scripting. It's for Macs only. Well, there is Windows scripting, but it's weird COM stuff. And I don't use Windows because I don't like it, and I don't understand COM. So if you know about that, feel free to find out about it. I prefer AppleScript. AppleScript is very old, it predates Mac OS X. The iTunes support in AppleScript is very old, it predates iTunes. Apple actually bought it from another company and rebuilt it, and the previous application has a very similar scripting library, funnily enough. It's English-like, so you tell application iTunes to repeat with cur_track in every track in the current playlist, to log name of cur_track and by and artist of current track. Then you enter the repeat and then the tell. That almost sounded like English. There are lots of things you can do with it. You can fix up metadata tags. You can select a bunch of tracks and you can say, well, this has got the artist and the album both in the artist field, because people like having artists called various artists. But they're stupid, and I want to fix that. So you can fix that, and that's pretty easy. You can create playlists. You tell it to add the current track to a playlist with the same name, and it does it. You can use it to control iTunes. You can tell what the state of iTunes is, and you can change its state. So if it's playing, you can pause it. If it's not playing, you can start it playing. And you can do that by binding global hotkeys. There are thousands of apps to do this. It seems to be the first thing everybody does with AppleScript. You can do it over Bluetooth using Salin Clicker and other applications. You can even do it over SSH, because Mac OS X has a OsaScript command which allows you to run scripts from the command line. And if you want to do anything more complicated, I expect it's probably the first tip if you look for iTunes AppleScript is DogScript for AppleScript for iTunes. And it's absolutely packed with things that you might find useful and you can click from, usually. And so that's pretty useful. There are some problems it can be really, really slow. If you have about 1,000 tracks in your library, don't try and iterate over every track, because you'll just be sitting there watching it for quite some time. If you're lucky, you can get it to do about 20 tracks a second, which isn't too bad. You can also try and minimize what you're doing. Instead of getting all information about the current track, if all you're interested in is fixing the album and the artist tags, just get the album and the artist tags. The syntax to do that looks really freaky, but you'll get the hang of it. There are also some things that it doesn't expose as scriptable. For example, you can't get a list of all the shared connections, which I'm going to come on to later, which means that you can't really script playing with those. You can't find out what their IP address is. Lots of things like that. And the selection is read-only, which is a shame, because sometimes it would be nice to say, well, I want to find the track with this name and highlight it, but you can't do that. I'm sure there are other things that you'll run into. Generally, though, it's pretty useful. Then there's sharing with other computers. This is something imagined to be called iTunes library sharing, because it shares iTunes libraries. It's read-only. You can pull tracks from the server, but iTunes doesn't give you a way of saving them locally. It goes over a protocol called DAP, which stands for Digital Audio Access Protocol. People think. Apple have never actually said what it's called, but that's what people assume it stands for. It's a strange binary encoding, but people pretty much got the hang of it within a couple of months. And it does discovery of shared libraries over rendezvous, bonjour, whatever it's called this month. I think they've sorted that one out now. It's just bonjour, which is a shame. Anyway, so you can't actually tell it to connect to a library. You have to wait until machines on their local subnet advertise themselves to you. How it works, pretty obvious really, but it's there are a bunch of DAP commands for this, and you can look up the commands if you, in particular if you want some of the Perl libraries for doing this. There are Perl C, Python, C++ as well, I think, and definitely Java libraries for doing DAP. Then it tells the machine that it wants to connect. The machine says, that's okay, that's okay. Then you say, I would like a list of all the fields you know about. So, and then it returns this big list saying, I know about albums, artists, and then there's really obscure stuff like what type of track it is and how long it goes on. There's loads of them. Then it says, okay, I want to log in. It says, okay. And then get all the tracks. And so it sends a big list of all the tracks. And then give me all the playlists. And it sends all the list of all the playlists. It's sharing, not streaming. Instead of being forced to listen to what the person who's using the host machine is listening to, you request the tracks you like, you can skip around within the tracks, and you can search for a song, so it works just like a local library. If you want to do streaming with iTunes, it's possible, but it's kind of a bit hacky. You generally end up redirecting the audio output through another application. It works like a local library, except you can't edit track info because it's read-only. You can't copy tracks locally because that's an iTunes limitation, because Apple didn't want you to steal music. You can't add tracks to a local playlist because they don't have a file location, and that's what Apple have decided that iTunes playlists need. And you can't edit remote playlists because it's read-only. So you might want to look at some other software. There are non-Apple DAP servers. The one I like is MTDAPD. It's multi-threaded, it works very well, and it's developing this ability to share via XML. It's got FLAC transcoding support, so you can store your music in high quality and then only stream it in low quality. There are various apps that allow copying. Blue Coconut, declare an interest, I wrote that one. Get It Together, Apple Records, OurTunes. Most of them seem to be written in Java for some reason. And media centers often support DAP. The Xbox Media Center Linux project supports DAP, so you can have all your music in a box in your study and stream it to your living room. And Slim Server, which is a rather nifty open source project that runs on slim devices, hardware, music streaming app, supports it. And I'm sure there are lots of other things that do too. The digression is that DAP sometimes breaks because Apple changed the authorization. They've limited the number of clients you can connect to, and they while they don't threaten to sue people unless you rip off their plugin code, they'll try and make it hard for you anyway by changing things that they can control. They tend not to. It's quite an interesting approach, but it's still a pain to work with sometimes. And if you're on the same machine as iTunes, I'm going to have to be really quick here. You load in the big XML file called iTunes Music Library. It's usually in your home folder, in a folder called Music iTunes. And if you're using Cocoa, it's really easy to pass. If you're not, it's a really horrible plist format, and people don't like it. But it does tell you every track and every playlist. But changing the XML doesn't change the library. It's sunk the other way, and it only happens when you make changes and when you quit. Possibly only when you quit. And it gets really big as well. I think I've seen 16, 20 megabyte files. That's a lot of XML to be loading in. So, in conclusion, iTunes isn't extensible like Winamp and presumably all the Linux players, where you have nice published APIs to plug into. But you can use AppleScript to make changes based on what's playing. You can use the XML to integrate the iTunes listing into your own applications. And if you have a network, then DAP is really quite an interesting tool. And I think it's a lot better than pure streaming. Thank you.
Coming up next, Myth TV, more Linux jiggery pokery, I think. Mike Ryan.
Hi. As you said, my name is Mike Ryan, and we're going to talk about Myth TV as I titled here on the slide, the open source PDR. So, start off on the first slide, what's a PDR? I think many of you are probably aware of a PDR. I've given two examples that are most well known by most people with Sky Plus and TiVo. Generally speaking, those systems, as I say here, are single function systems that allow you to record and watch TV at a later date and do not much more than that. So what's Myth TV? Myth TV calls itself the mythical home media convergence box, and there's a nice quote at the top there from Isaac Richards, who's the founding developer of the open source project, and gives you the background of where the actual name itself came from. Now I'm going to go through, this is the opening screenshot of the software itself when you run it on your television or however. And I'm going to quickly go through the function of the system so that I can concentrate a little bit more on how you actually build one of these and install it. So if I go through the modules here. The basic TV features of Myth, as you'd expect with most PDRs, with live TV playback, you've got all the usual things that you'd expect: play, pause, rewind, fast forward, recording, and change channels. Moving on, we've got the recorded TV side of things, where you get the list of all your previously recorded programs, you select them and play back. All the usual features I mentioned before, plus the additional option of deleting as well, because there's previously recorded programs. Then there's the scheduling recordings. Again, you've got the choice here of just when you schedule recordings to do a one-off recording. But it gets really interesting when you do multiple recordings, and many PDRs support these kind of functions, but Myth takes it a lot further, because you get the options of having multiple TV capture cards, so you can set multiple channels to be recorded, reoccurrences, number of recordings to keep, and you set a priority as well, so if you deal with any conflicts, if the system's trying to record two channels, two programs at the same time. Some of the other modules available, there's the ubiquitous MP3 player that comes with the software. There's a module called Myth Weather. When you set the system up, you actually define your local addresses. I've set mine up for London here, and it brings you up a scrolling weather forecast from the Weather Channel, and a 3-day weather forecast as well. And there's RSS newsfeed reader built in. And as you see, I've selected a few here on the left-hand side, and we've got the BBC headlines there. And what's really good about this is, you can get it's standard RSS newsfeed, but if you want more information, you just hit space or press OK on your remote control, wherever you've got it configured. And it'll actually kick off its own built-in internal Myth web browser as well. And as you see, I've got you can use it as a standard browser as well, but I've selected the BBC News website with a great headline there at the top as well. Myth itself, it also has some other modules which I haven't shown up here. It also has the ability to play CDs and DVDs, and it also has a voice over IP internet phone option as well. And new modules are being added all the time as the software becomes expanded. It also has a web interface, and this is really useful. If you've got a system configured with a permanent IP address, you can connect to it from obviously anywhere on the internet, and you can see what's on TV tonight, and You also get, you can ask it, set it up to record programs that evening as well, or whenever you like. And it also brings up a list of all the previously recorded. And you see I've got the programs here. And what's really... Oh, sorry. I'll go that way. On the left-hand side, we've got the little images of the programs. And when you set the system up, you tell it how far into the program you want to capture these little thumbnails as well. Because often programs run a little bit late and stuff, so if you just had it at the beginning, you just end up with the usual end of the 9 o'clock news or whatever. You can also delete the program, selecting the delete option on the right-hand side. I found this really useful. I was actually on holiday all this week and realised I hadn't set the Mythbox up to record extras, which I wanted to record, so I just went to my local internet cafe and set that up. So, how does it all work? As we go through the setup here, as I say, it's just a commodity Intel PC architecture. There's nothing special at all other than a TV card. The Linux operating system, I used Fedora when I set mine up. You can use Debian or a few of the others. And obviously the MIF-TV software. The internet connection, as I say, is optional, but when you're actually setting the system up and you want to bring it up to date, you need the internet connection. And there's the basic hardware configuration. Well, on the left-hand side, I've actually drawn out a really simplistic diagram of a PC system that you need. You've got the TV capture card. You can have one, you can have more. Depends how many PCI slots you've got. We've got the TV out card. You can actually hook your system up to a standard television, obviously if you've got the correct sort of card. I'll show you my configuration later on when I've got a DVI out, but or you can just hook it up to your monitor using a standard graphics card. We've got the sound out. Down the right hand side I've listed some sort of basic requirements really. The CPU, what's interesting there is you can actually, I'm sure many of you have got lots of old kit that you've got sitting around your house and you're not using, and what's really good about it is that if you use a DVB card, as most people call a Freeview TV card, it uses very little CPU because it just dumps the raw digital stream to the hard drive. So if if you want to try this out, you've got some old kit, just get yourself a cheap Freeview card off of eBay and give it a go. If you see on the left there, I've also split the MIF-TV back end and front end out into two separate blocks. What's important about that is the back end can run somewhere completely different to the front end. And the front end actually supports a number of different architectures. So I understand there's a build of the front end available for the Mac Mini. You can also run it on an Xbox if you're running Debian, and also the Xbox running the Xbox Media Center. And I'm sure there's probably more out there I'm not aware of. The hard drive I've said 5 gig plus was obviously how much size depends on how much you actually want to record. It normally takes about 2 gigabytes per hour. So there's a basic MIF-TV installation. I'm assuming that you've got all your CDs ready and you've got an ADSL connection, and I've estimated 2 or 3 hours, so I mean, it's sort of an evening's work if you want to play around with it. Basically install Fedora core, then run apt-get, and actually bring all the packages on the system up to date. Once that's complete, then you do the MIF-TV install, again using apt-get, and apt-get will deal with all the dependencies. And that 2 to 3 hours is pretty much the end of point 3 there. So point 4 will take you, however long it will take a while to configure your system up, but there's some great web walkthrough documentations with a link at the end for that. There's the current configuration I've actually got at home. You see, I've got a bit mad. I wanted to get myself, I wanted to get a bit ready for the high definition world whenever it comes. So I've got my system ready to go. See, interestingly, on the left down there, about 2/3 down, I've got 2 DVB capture cards. And what's great about this is that I can watch one channel, have picture-in-picture, record 2 channels, and watch a previously recorded program. And there's very little CPU overhead on those cards. And that's my system in all its glory. Now, I know a lot of people take pictures and they hide all the cables, which I have done to a certain extent, I'll be honest. But it generally is as simple as that. I don't need a DVD player, I don't need a Freeview box, I don't need a CD player. That system handles it all, it does the whole thing. And even my 2-year-old kids use it, but then they love Teletubbies. The current MIF-TV status is the latest version, 18.1. What's been fantastic, the last year, the support for Freeview cards has come on in leaps and bounds. Obviously Freeview, the DVB is not really big in America, but it is in the UK, Europe and Australia. And to set the system up, all I had to do was probe for the cards and then define them in MIF-TV. And I didn't need to do anything else. MIF-TV configured all my TV channels, downloaded listings, nothing more to do. What I've listed there is a few features that are available in the latest version of code. The one I listed at the top there, playback at 1.5 speed. Sounds like you think, well, what use is that? Well, a lot of the documentaries on TV these days, they always talk very, very slowly, so you can understand them. So it's all fantastic because you can actually watch them at a normal speed. And MIFTV will actually lower the pitch so they don't all sound like they're squeaking on helium. And you can watch a 1 hour documentary in sort of 35 minutes and you cut out the adverts as well. Grouping with recorded playbacks is another great feature if you've got small kids. If we've got 10 episodes of Teletubbies recorded, I can just select each one of them, press play, and it will play them all from beginning to end. I don't have to come back and swap DVDs or anything like that. Automatic job queuing is another great feature that I'll quickly show. It allows you to automatically run a job against a recorded program. So if I've got a program, I can say to it, well, I'm going to play this one at a late date on my PSP portable. And so I've got an example here of, say, here's the news from the last night. And I can ask MIFTV to just automatically do that and then just convert it straight to the PSP. I upload it the next day and I can watch it on the way to work. There's loads and loads more features in there, and I'd encourage you, anyone's interested, to have a look at the release notes. Future of MIFTV, obviously regular updates. This is my take on MIFTV. I should be sure I'm not into the heart of the development community, but there's a huge global development effort all around the world. People are working on this. HDTV is already well advanced in loads of other countries outside of the UK, obviously, and so when we're ready to go, MIFTV is ready to take advantage of those. More pre-built distribution and easier installations. It's certainly a lot easier than it was a year ago. And commercial tie-ups. There's a couple of commercial vendors, one in America, one in Australia, are actually selling these. And there's a few links for anyone who's got any more interest. I think this will be available on the web later, won't they? So, thank you.
Okay, we're going to have one last speaker, and then we're going to really go open for questions, debates, answering, or whatever. Michael Sparks joins us now. Camellia. Yes, please. Okay. Right, and it's about Camellia, which is a new delivery mechanism from the BBC or something? Sort of. Yeah. Sort of. There we go. Okay. Pronunciation as well. Ladies and gentlemen, Michael Sparks.
Okay. I work in BBC R&D, basically, yes. What is Camellia? Okay, I'm going to do this in the style of a lightning talk, so I'm going to whiz through these really quickly, because I've planned for about 15 minutes, so anyway. What is it? It's a mechanism for building systems out of components, in the same sort of way you build Unix pipelines, kind of, but much more like the way you build hardware systems. The idea is that we want to make it quick and easy to build interesting systems, reusable, in a way that's fun, it's simple, it's easy, and also naturally concurrent. That's kind of important. It also aiming to encourage heavy reuse, much like you do again with Unix. When you write shell scripts, you very rarely rewrite ls, for example. I mean, it's a silly example, but it's true. It's from BBC R&D, this is kind of a what, but it's not really Unix. What is it? Well, we have, instead of pipeline here, called graph line. So that's a graph line. That's a graph line. What can you send through them? Okay, with Unix pipelines you just send text. With graph lines you can send any data object. And it doesn't matter what it is. Much like the Unix environment, we also have a system environment, but again, instead of just being strings, it's any data object, and you can look up data objects. We also have a concept of services, which is kind of a bit like where's ls on the system, is one way of looking at that. Okay. Alright, why are we doing it? We want to, the BBC states that it wants to put as much content online as it possibly can. Whether it's going to get there or not, I don't know, but that's what it states it wants to do. But it does actually want to do this. There's a whole load of things that need to change. Protocols need to change because most open standards which people currently use just will not scale to the levels that people currently want. Open standards in network world means open source. I mean, things like HTTP, SMTP, DNS, NNTP, all had initial implementations which were largely open source. Actually, some of them predate the terms open source or free software. Things like TCP/IP was sort of like 1980, it was way before free software was even spoken about. It's called common sense back then. We need new approaches to scaling. I mean, if you look at the way hardware is changing, Hardware is becoming massively parallel. You just need to look at things like the way PlayStation 3 is going, Intel's talking about 100 core CPUs, all of these sorts of things. And currently most people think software concurrency is really, really difficult, except they can use Unix shell scripts, which are kind of simple. And everyone, there's bucket loads of laptops around the place. They're all written using VHDL, which is software. So people tend to, it's mainly software developers who think concurrency has to be difficult. And I don't think it does, it's just the tools which you use. And that's partly why we're working on Camellia. Is it the right answer? I don't know. But if we don't start somewhere, we won't get anywhere. Okay. As I said about who's doing it, the reason I'm saying this is not because of the three of us who have done most of the work on it, but maybe because we've got a pre-university trainee who's worked with us for 3 months, who worked and built a simple streaming server which streams to mobile phones, and he did all the interesting stuff, and he came up to speed, learned the system, built the system to stream to mobile phones in 3 months. That includes learning Python from scratch, and we haven't really done much programming before. Currently, we've got Tom Gibson, who's only with us for 6 weeks, so we're giving him something harder. And he's done 2 years at university, so it's kind of fair because he's done a bit more experience. He's had no prior experience with the technologies we're using, those got no experience with multicast, and what we're trying to get him to do is basically make multicast useful in terms of lots of people have got multicast deployed, but there's lots and lots of islands, and you can't really have it over the widespread area internet. So what we're getting them to do is kind of, I'll talk about it a bit. And the idea is that anybody can use it. If you want to use it, feel free. If you like the ideas we're doing, come and tell us. If you think it's suck, tell us. We want to know. Example systems that you can currently do, with examples which are included are a simple streaming server for streaming off orbits over TCP, over a simple, reliable multicast protocol. We've got graph, network graph viewers, and things like the blobs you saw about 2 minutes ago. A simple command line shell. So in the same way you can build pipelines on the Unix pipeline, on Unix command line, you can build Camellia systems on the command line as well if you want to do that. It's very good for building systems ad hoc and prototyping. You can build simple games, network streaming, subtitling, and presentation tools, including this thing. Platforms it runs on, it's written in Python, largely because we're prototyping initially, but probably it's going to be fast enough anyway. We do also have a preliminary C++ version available, if people prefer C++. It runs on Linux, macOS, Windows, Nokia Series 60 mobiles. There's also the Mimo platform which is coming out, should run that perfectly happily. And you can probably write components in most of your favourite languages, although Python is the main one at the moment. So how do we do it? Essentially what we do is we say components are things which are a single class and it does something. I mean, if you run LS, it's a program, it runs, it's a process. With our stuff, it's the same sort of idea, but it's a class and it runs. So as a result, you communicate with it using inboxes and outboxes, much like you have standard in and standard out. And with hardware systems, you have input channels and output channels. We have a scheduler, and we have something called a coordinating assistant tracker. That's partly a pun, because there's a postman actually does the deliveries between inboxes and outboxes, and if you've got a postman, you need a cat. The idea behind the cat, though, is kind of useful. It provides you the idea of a system, of the Unix system environment, and you can look up services like, is there somebody who knows about network sockets in the room, for example, is the concept. Is there somebody who knows about, is there a display? That sort of thing, that's what it does. So, what's available with it? Well, this is kind of a slightly more detailed version of the previous slide. Basically, the game system and windowing system is a wrapper around SDL. It's using Pygame, for those who know about Pygame. There's a Pygame simple game toolkit for that, so you can build sprites and you can have sprites run as run a scheduler, so you don't have to worry about telling the sprites, oh, you must move over here now. Boring. Basic integration with TK, so if you want to mix Pygame with TK, you can. If you want to mix that with a very limited file system, like for example you want to stream something out to a network connection, and all of these things can be used together in the same way that you don't care which programs in /bin work with what other programs in /user bin and all these other things. You don't care about this with components. Yes, there may be data differences between them, and you may need to put some adapters in between these things. But generally speaking, you can just bolt things together very, very rapidly. Okay, where are we up to? What are we working on at the moment? We're working on the swarming peer-to-peer component. This is not actually re-implementing existing wheels. This is the idea behind this is to show people how to integrate existing peer-to-peer systems into the system. Because if we don't do it, somebody else is going to find it a lot more difficult to do. Whereas if we show this is how you can do one, it's a lot quicker for everyone else to pick it up. We've got Tom's currently working on a generic multicast tunneling overlay peer. The idea being you run one of these things inside your network, and you can pick up BBC content or somebody else's content, which they're multicasting, or somebody else's, but you can choose. So you can actually join, as for example, your company's multicast network to somebody else's multicast network. It seems kind of silly, but it's kind of useful because it means you can actually pick up the news, which kind of might have been handy this week. We've got things like GUI for building pipelines, which we'd like to be able to do. It's fairly trivial to do. We just need to bolt together the thing that's got the graph viewer with the TK component, so you can pick and choose which things you want to put inside pipelines. The idea behind that, though, means that people, normal people, not just programmers, but average people, can build interesting systems. You see things like Star Trek, where you get somebody who says, "Oh, I'm going to build this system." They say, "How long will it take?" It says 5 minutes, and the captain says, "You've done it in 30 seconds," and you're sitting there thinking, "It's going to take 4 years." That's where I want to go, and that's the idea, one of the drivers behind Chameleon internally. Other sorts of things, what do you want to do with it? I mean, what do you want to see in 10 years' time? Wouldn't you rather see it next week, or next month, or whatever? We'd like to try and speed things up so we don't have to continually reinvent the wheels. We want to be able to assimilate technologies rather than reinvent them. So I just want to whiz through some example pipelines so you can see what I actually mean. This is a simple streaming system. You have, that's a simple server. You have a file reader which is run every time somebody connects, spans out the network connection, sends across the TCP client, goes through a voice decoder and an audio playback. And it's pretty much what you'd want to write, and it's the sort of thing you can write on command line using things like netcat. But netcat can only deal with plain text. If you want to do multicast, you just replace the TCP portion with multicast. Since the multicasting spits out actually data and who it came from, because it's kind of useful with multicast, it needs a small adapter, which is a detuppler, because it spits out a tuple. It's kind of boring, but it's kind of useful. And that just works. And the server has just changed to use multicast transceiver as well. The next thing is make it more reliable, because if you use multicast, everything just gets thrown away. Because multicast isn't deployed, so routers say, "Oh, I don't care about that, I'll throw that away," because there's important TCP traffic that needs to go on because somebody browsing the web for something really, really interesting. But what you get is, as you can see, it's just inserted a layer for the protocol and another layer for the other protocol. The code itself is otherwise unchanged. I've just highlighted what's changed in bold, which probably isn't very visible, but these are all examples which come with the distribution. Okay, a simple presentation tool which I've used in the past, it's not this one, looks like this. It has a chooser which loops through a list of files, which might be a bunch of images in this case. It's a bit cheap. But there's also things like, it mentions a variety of buttons which are all just linked in. So you have all these buttons here. Where are they? That's the image. So all these buttons here, you click on one of those send a message to their outbox, say, somebody click this. It doesn't say what it means, but it's just, somebody click this. Goes to the chooser, which then spits out a file name, and the image just displays it. Which is exactly the same approach which you get with Unix pipelines. These things are reusable in lots of different locations. It's kind of where we're aiming for. Okay. This is a more complex one. This is from the simple game example, which I'll show right at the very end, which is a very simple game designed for 3-year-olds. Press one button, you add something bounces around the screen. Press another button, something else bounces around the screen. And in terms of graph, it looks pretty much the same thing. You have the thing that's doing the bouncing, and you have a bunch of components that control it. And then it's got something to do with this shutdown, and shutdown just gets a little bit awkward because you need to be able to have that tell everything else to shut down as well. Okay, so how do you write components? Well, we're trying to make concurrency easy to do, so ignore concurrency when you're writing software. I mean, when you write shell scripts, you don't, and when you write most Unix programs, despite the fact they can be run in a concurrent way, you ignore concurrency. So we do the same thing here. This lends itself, but it tries to solve the simplest possible version you can think of. Like, I want to show a picture. Okay, let's try something that shows a picture, not something that shows a picture and then does some fancy slide, screen changes and all these fun things, because that can be done by something else. Just the thing that shows the picture, because then you can do an interesting slideshow. That lends itself to test-driven development, which is very, very nice. It lends itself to test-driven development with network protocols as well, which means we can just completely throw away the network when we're designing a network protocol. Do all interesting things and then test it inside a network again in an interesting way. So then we change all the inputs to inboxes, and we change all the outputs to outboxes. But during testing, you don't have to do that. You just write it the simplest possible way you possibly can, and then componentize it, only if it makes sense, of course. This approach tends to generate small reusable components, very much like the standard Unix ethos. And the result of that is you can end up with more scalable and simpler systems for people to look at. What does a component look like inside? Well, I've made important bits P, which is probably just as well. Essentially, it's just a class which derives from a certain base class, which says it's a component. It's got a specifically named method, and it sends messages to its outboxes and receives stuff from its inboxes. And this example is with a few minor details which have been deleted, which is boring socket things. It's a multicast transceiver, which is mentioned on the previous pages. So that can be used as is, and that's nice and simple to look at. So if you're actually trying to debug it, because it's simple to look at, it's a lot simpler. Because you don't have to figure out, is it a state machine? Okay, what does this state machine do? Who wrote it and were they nuts? So the fun ideas which I just want to finish on before showing just that brief examples. A bunch of fun things you could do with Camille if you really wanted to right now. Yeah, that's it, came to mind. A paint program using alpha blending. PyGaming supports alpha blending, it's very trivial to use. We have PyGaming integrated, you could do it quite trivially. Rapid graphical systems building, which is kind of what I was meaning with the UI, so perhaps you could do it if you like. Well, if you don't do it, I'll do it. But. Shared whiteboards, joint rooms over network points using cheap projectors. I mean, these things are about 500 quid these days. So if you have 2 offices in 2 locations, well, you buy one of those, and you just join them together using a small network pipe. And suddenly you've got one big shared common room between 2 offices. It's trivial to do, it's easy to do, but it's hard with existing systems, and it shouldn't be. And that's the idea which we're talking about. Things like a nice 3D sprite component would be kind of fun as well. I mean, we've got 2D games basically assimilated, we must have 3D assimilated as well. Stuff we're probably going to be working on is things like automatic compute distribution of these systems over clusters. So they're naturally concurrent. So, okay, CPUs with 100 cores aren't going to be available for a while yet, but you can buy 24 Mac Minis for about 10k. So that's actually quite an interesting idea. Things like a central component repository. And the reason why Unix is so useful, another reason for it, is because /bin has got lots and lots of things inside it. So that's what the important idea behind a component repository is. You want to be able to do code migration. So you build a system, you might want to take it with you. I mean, we run on mobile phones, and we should run quite happily on Nemo, which is a nice pocket PC, but running Linux type system, and you have to take it with you. Kind of nice, rather than have it stay in one place. And since we've actually taken the same sort of approach to this hardware, there's a project called MyHDL, which is a Python project for modeling hardware systems using Python, and a very similar approach. So we should be able to compile to that as well, so it's kind of fun. That's it. I just want to show, I think, pictures. Hey. You left click and you add a picture, right click and move on. And it's designed for very, very small children. 2 to 3-year-old.
Dave Freak's still in the room.
They love it though.
So, anyway.
Okay, great. Thank you very much.